Hello, this is Miss Taylor, and I am going to show you how to use the chain rule to find the derivative of composite functions. So this statement says, if y equals f of g of x, then dy over dx equals f prime of g of x times g of x. A composite function is a function within a function, so that's why it says f of g of x. And according to this rule, I take the derivative of f with g of x still plugged in times the derivative of, and this should say g prime of x, the derivative of g of x. So in words, I could describe this as the derivative of the outer function with the inner still plugged in. So with the inner still plugged in. The other way to think of that is, I always say derivative of the outer, leave the inner alone, and then times multiplied by the derivative of the inner function. So derivative of the outer function with the inner still plugged in times derivative of the inner function. And so let's look at some examples of the difference between problems where you use the chain rule and problems you don't. So for example, if I have these two functions, the one on the left, y equals x squared plus 1, this is not a composite function, it's a polynomial. However, if I put that same polynomial in the square root symbol, that's a composite function. Your inner would be x squared plus 1, your outer would be the square root. With trig, sine of x is not composite, it's just sine of x. However, if you put a constant inside the angles position for sine, that becomes a composite function where 6x would be your inner and sine would be your outer. 3x plus 2 is just a polynomial, but if I raise it to the fifth power becomes your outer function. 3x plus 2 becomes your inner. And then x plus tangent of x, not composite, but if tangent had an x squared. And again, I think I touched on this in class where it all depends on the parentheses. Since there are no parentheses, this is x squared. X is the only thing being squared, so this is an inner function. Tangent is your outer, that's composite. So those are some examples of functions where you'll use chain rule here because you have composite functions, and where you will not here. Let's apply the chain rule. So in words, it was derivative of the outer derivative of the outer with the inner still plugged in times derivative of the inner. So the first thing you have to do is decide what the outer and inner are. And so here it's d over dx of sine of x squared plus x. You could say the derivative of sine of x squared plus x with respect to x equals. And so my outer function is the trig function sine, and my inner is x squared plus x. So derivative of the outer, the derivative of sine is cosine. Leave the inner alone times derivative of the inner. Now, I see this a lot. The way this reads is cosine of x squared plus x is the only thing being multiplied by 2x. However, you need to use parentheses to show that it's times the complete derivative of the inside function. So that would be my derivative for sine of x squared plus x. One more. So in this one, differentiate y equals x plus square root of x all raised to the negative 2. My outer would be the negative 2. My inner would be x plus square root of x. So the derivative of the outer, multiply by negative 2, leave the inner alone, subtract 1. We're using power rule because our outer function is an exponent. Subtract 1 times derivative of the inner. Don't forget parentheses. Derivative of x is 1. Derivative of x or the square root of x, same thing as x to the 1/2. So we multiply by that 1/2, subtract 1 from 1/2, you get negative 1/2. And that would be my derivative. Now you may be inclined to simplify, but remember I'm trying to get in the habit of not simplifying to eliminate errors. So what I would like for you to do is I would like for you to work out these 4 on your own using the chain rule. Pause the video, and then once you get them all worked out, hit play and the answers will appear. So here are the answers, and as you can see, for some of them I did simplify just so that you can see what they would be simplified. And if you have any questions, feel free to bring them up in class.